the representative for Summit 3, and this is our presentation for our design. As you can see, GLL Invention Challenge, and our title will be DIY Safety Signaling Kit. So first of all, insight. As a high school student, this is a comment from one of our team members, Mike Nguyen. As a high school student, I ride the bicycle to school almost every day. However, riding bicycles can be dangerous as there's no signaling system on my bicycle, and hence other vehicles can collide into me when I make a turn. Our explanation to the insight is that bike riders, bicycle riders, and even their manufacturers don't consider dangers not having turning signals. This is especially hazardous in a country where bike lanes are rarely seen, if seen at all. I've been living in Hanoi for as long as I can remember, and I haven't seen a single bike lane in the streets. Our problem is that as a bike makes a turn without signaling, faster vehicles behind it which are rushing and which the bicycle cannot see may be surprised, leading to possible collisions. For a normal bicycle, the only solution is to extend the arm out to signal or turn the head to quickly catch a glimpse of the vehicles behind. And for an inexperienced biker, or bikers in general, these actions can be really dangerous as they may lose balance or not see dangers ahead of them. Our solution to this problem is a simple DIY signaling kit for bicycles. The mechanism is extremely simple, and it can be understood and assembled easily by primary students. Teach students about the usefulness of science and about underlying safety issues in Hanoi in particular that should be looked out for. So, the mechanism. These are our rough 3D models so far. It portrays the main component here, which I will explain later. This is seems to be the bicycle handlebar in here. The mechanism is inspired by that of the metronome, a weight below the rotation axis, lighter visible part above. In addition, small weights will also be stuck to the ridge flag to create an inclined equilibrium state, allowing the oscillating flag to bend and extend the farthest to the sides. Okay, as seen here, this is the metronome-inspired mechanism that was mentioned. The weight is stuck on either sides of the extension, and through that it creates an oscillating movement. So there that is. Initially, the flag is placed above its equilibrium state, so it's upright, and it's held in place by an inclined bar. So maybe there's a bar right here to hold it in place. And when the biker wants to start signaling, the bar is pulled to release the flag and give it energy. The energy is given by maybe subtle movements while riding the bike. So here it's upright, and there's an inclined kind of thing to hold it in place, and the bar is pulled. and then that allows the extension to freely move around. And with a little push, it can start moving by its own, swinging back and forth to signal the vehicles behind that this bicycle might be turning, and that maybe I should look out for it. So when the signal ends, the bar can be pushed back into place just when the flag returns to its highest position. So when it returns here, it can be pushed back. Cool. Now, target audience will be students from kindergarten to secondary school. And why we chose this specific group is because they are the most vulnerable to the problem and not being fully developed, because they are not fully developed and experienced. And furthermore, they are the future generations, and in a way we're helping out a bit by educating them with hands-down experience, because our idea is that this is going to be disassembled into parts, and on receivable there will be instructions to how to reassemble this particular device and how it works, how you can use it, how it prevents things, maybe, and it gives people hands-on experience with pendulums and an underlying safety issue of bicycles not having signaling devices. Our product objective is to raise awareness of the importance of signaling, especially in Hanoi, where the traffic is usually very busy, and signaling is essential as bicycles are less conspicuous, and bicycles don't have independent lanes. So our product can also encourage young children to commute by bicycle using the device, and it can also improve traffic safety. So our summary of the whole presentation. First of all, we have our problem. People, especially teenagers, do not realize the importance of signaling while riding bicycles, which can lead to accidents. Yeah? And our solution is a simple DIY kit that could be assembled into a signaling system for bicycles. And the people who use this can freely customize their products. As for the mechanism, it's a flag on an oscillating pendulum, started and ended by an inclined bar, which in turn is pulled or pushed by the fingers. Our objective, we believe, is to raise awareness of the importance of signaling and to improve traffic safety. Thank you for listening, and we hope you enjoyed our presentation.